All right. Good morning, good afternoon, and good evening, everyone. Welcome to this class for the Private is Remote. And today I will present you a class on how to develop and build a Django REST framework application and deploy it on OpenShift. I left in the chat of the live event a link to the chat room we are using for questions and like general chat. So please feel free to join, and I'll try to monitor it. And if there are any questions, do not hesitate to ask questions while I'm presenting the slides and I will stop and try to answer the question as they come. With that, let me share my screen, and we should be able to start. All right. Okay, so just before we start, a few words about me. So I'm working on the Fedora project, which is the main goal of the project is to release the Fedora Linux distribution. And I'm lucky enough to be paid by the company called Red Hat that pays me to work full-time on this project. So I'm a senior software engineer at Red Hat, and I'm part of the community platform engineering team. And my main focus is on the Fedora infrastructure applications. And so I put some links here to our GitHub accounts where we have most of our application. And we are using a lot of Python. So if you are interested into contributing to some open source project, feel free to have a look at the project we have there, and you are more than welcome to look at easy fix tickets and send some pull requests if you like. So what we're going to talk about today, so there will be a few slides, not many, but just to make sure that everyone's got the basic understanding of what is REST service and what is the Django REST framework, what is OpenShift. And once we went through those basic notions, I'll be doing a small demonstration. All right. So what is a RESTful service? So we usually, when you hear someone talk about RESTful service, it means that it's pretty much server application that accept some HTTP request, and based on the request, it will return some content. So this is mostly used in a client-server architecture, and here you can see in the small diagram that most of the time we use, actually all the time we use HTTP request and HTTP method to request some content from the server. And the server will answer those requests and send to the client some data. In the world of REST services, there is a design pattern that is commonly used. So that's the CRUD design pattern. And it's very useful when you have a service that interacts with some data. So as you can see, the basic operations are create, read, update, and delete. So it's pretty much common operation that you do when you want to manipulate data. So where this is powerful is that for each operation, it's actually mapped to an HTTP method. So if you want to create a resource on the server, you will use the HTTP method post. If you want to read, you use get. If you want to update a resource, you use put or patch. We will see later what's the difference between those two. And if you want to delete, there is the HTTP delete method. So this is quite useful, and it encourages best practices because you have actually one operation per method. And if you are a client and you wish to use the server APIs, it makes it you don't have to find out the endpoints that you have to call to create, delete, or update. You just reuse the same URL, and you just have to change the method of the HTTP method that you use in the request. So we will see later in the demo how powerful it is. So next slide. So the Django REST framework. So Django is a very popular web framework written in Python. Actually, it's the most popular framework with Flask. And the nice thing with Django is that it provides a lot of boilerplate code that it's already there, and it's very, very quick and very efficient to set up applications. But the actual Django framework is very focused and designed on building web applications. So when you have like a front end where you want to serve HTML and where you're actually building a full application. And that's why the Django REST framework, which is library or actually a framework that is built on top of Django. So the Django REST framework has been developed, and the main focus of this framework is to actually build REST service and REST API. So like in the spirit of microservices, just a small service that will do one thing and doesn't take care of rendering HTML or things like that. So like something relatively simple. It's opinionated, and it encourage best practices. And we will see that the CRUD design pattern is actually built inside the Django REST framework. So the Django REST framework, how does it work? And it's the first thing that you want to do. It's actually to define a model. So the model will be where you define your data and how you want to store the data in a database. It actually doesn't use the Django REST framework. It just uses plain Django. And in Django, you have an ORM, so that lets you interact with a database without the need to write your own SQL statements. The next thing, and that's where we start to actually go into what the Django REST framework gives you. It's called a serializer. So the serializer, it's actually used to convert your data model to an output. So most of the time for REST services, this output will be JSON, but it could be XML, for example. And the serializer is also used to convert JSON back into your data model and store your data. So you have the two use cases when actually the server wants to deliver data to the client. The serializer will take the data from the database, serialize them into JSON. And when the clients want to send data to the server, the serializer will take as an input JSON and will convert it and store it into the database. So DRF provides like different kind of serializer, and we will see that we will see one in our demonstration, and it's the model serializer, which is very, very useful. But there are also some other type that allow you to do some a bit more complex use case. The next thing or concept of DRF are the views. And the concept of views is actually how the server will present the data to the user. So DRF gives you the possibility to have one view per action, and here we will see the same action and the same operation that we saw earlier in CRUD. So list, create, retrieve, update, and destroy. All those are views that the Django REST framework provides you. And something very useful in DRF is the view set. So a view set it's a group of view, and when you want to build a CRUD API, you can use a view set that will group all the operation that you need to create, read, update, and delete some data. So by default, the model view set, it's what we will be using, and it's giving you CRUD out of the box. So once we have our model, our serializer, and our view, we need a way to map this to an endpoint or a URL. So our clients have access to the data. And that's the job of the router in Django REST framework. And as you can see in the schema, it really, and as you can guess from the name, the real job of it is to route an endpoint to the correct view. So when a client will request an URL, the first thing that the Django REST framework will do, it's from the request, get the URL, and the router will call the correct view. Then the view will serialize the data if there were any data provided to the request, and it will store the data into the database. So now that we've seen a quick overview of DRF, we will go into a bit more detail after once we go through the demo and we will look at some code. But now we can have a quick overview of OpenShift and what is OpenShift. So OpenShift is the Red Hat Enterprise distribution of Kubernetes. So Kubernetes is a system that allows you to manage and orchestrate containers. The open source version of OpenShift is called OKD. So if you look online and you want to try OpenShift on your local machine, you can download OKD. The main focus of OpenShift compared to Kubernetes is that it focuses on the developer experience, and it provides a lot of tools, and it makes it easy for a developer to actually deploy and automate deployment of an application into OpenShift. And it's relatively easy to run locally, so you can use the OpneShift. It works on Linux, on Windows, and on Mac OS. And basically, just like create a virtual machine on your local machine, and it starts everything. So later in the demonstration, I will be using OpneShift. Also, at the end of this presentation, I added all the links to the where you can get more information about all those tools. So looking into a bit more details at OpenShift and how it works, you can see on this diagram how the OpenShift cluster looks like. So you have a master node where that will manage all the requests. So from the developer, how you configure your application, from which, for example, from which project on GitHub you want to build a container. If you have also CI/CD, so continuous integration and continuous delivery, that's all the configuration and how your application will be built and deployed happens on the master. And then you have the concept of nodes. So nodes are actually virtual machines or physical servers that are dedicated to run the application. So they will be running containers. And the master, the OpenShift master will orchestrate those nodes, and it will scale containers on the different nodes and in function of the load the application has. So if we need more machine, the master will be able to scale more containers. So actually, containers are running in what is called a pod in OpenShift and in Kubernetes. So a pod, it's where we will be running our containers. And you can run one container per pod or multiple containers per pod. That's, I think, all the information we need for now. It's also interesting to see that there is a container registry in OpenShift. So you can actually build application from source, and that's what we will be doing. And once those applications are built into container, they will be stored in the OpenShift registry, so they can be accessed after later. So one of the things that OpenShift has, it's the ability to build application. It's using the source to image project. And what it does is that you can actually build directly containers from source, so from a Git repository, and you don't need to write any Docker file. So that's very interesting if you want to do continuous deployment. You just have to configure OpenShift to look at your Git repository, if it's hosted on GitHub, GitLab, or your own Git server, and you don't actually need to spend some time to develop a Docker file. The source to image will be able to analyze what is in your source repository, and it will be able to build the application, to build the container directly from the source. The next concept of OpenShift are deployments. And it is where you configure how you want your application to be deployed. So once the build operation is finished, you will have a container that has been built and stored in the registry. Then after, you need to tell OpenShift how you want this container to be deployed and how many containers you want. Do you just want one container or multiple? And also you can tell OpenShift how do you want to automate deployments. So for example, every time a new container is built, you can tell OpenShift to replace the currently running containers by the new one that's been built. You can also ask OpenShift to do automated deployment on a configuration change. So if you change any configuration in your project, you can ask OpenShift to automatically deploy the new version of the configuration. And obviously, you can also manually trigger the deployment if you prefer. So what I'll show you today is how you can configure a CI/CD pipeline and how from an application hosted in GitHub, you can open a pull request, trigger your test, and once your tests have passed, how to automate the merge to a branch, and based on this merge, how you can automatically deploy the application in OpenShift. So that's very nice because you can actually just from your local machine, you can push a commit or push a pull request to GitHub, wait a few minutes for the time for the CI to run and for the merge to happen and the new deployment. And a few minutes later, you have your new application running in production. So now we will go for a live demo, and hopefully nothing will go wrong. Before the demo, we'll look a bit more at DRF and at some source code. So the application we will look at is a simple to-do service. And let's have a look. So let me share my code editor. All right. So if you have any question now, please feel free to ask. Otherwise, I will continue. Okay, so I will be looking at a project that is available on GitHub. You can actually clone it from this repository. So just checking if you can see the text that might make it bigger. So as I was saying, this application is pretty much a server service that manages tasks. So when I was talking about DRF, the first thing we saw was the model and how you model your data. So a DRF application is very similar to a Django application, and how it works, it's that you have a project. So in my case, it's the project to-do app. And inside this project, you will have one or many applications. And in our case, the application is named to-do. So in the to-do application, we have a file called models.py, and that's where we will write the representation of the data we want to store in our database. So our to-do application, what we want to store are basically tasks. And for each task, we will have 3 attributes. So a title, a description, and a status. And the status will be one of those states. So either to do, either work in progress, or done. So as you can see here, I'm just using plain Django. There is no reference to the Django REST framework. This is just the Django ORM and how you define your data in the model, how you model your data. So once we have this, we can look at the serializer. And this is where we start to use the Django REST framework. So we are using the model serializer. And what this class does for us, it actually allows us to give the serializer a model. So in our case, the task model that we defined previously. And we can ask the serializer to serialize all the fields, which is the case here. So if we do a GET request, the server will get the data from the database, all the tasks we have, and it will translate the representation that we have of a task in the database and convert it to a JSON representation. So all the fields, but we could also, if we wish, only request the serializer to give us only certain fields. So for example, if I want only the title and the status, for example, I don't want to see the description. I could specify this like that. So in our case, we will get all the fields. So now that we are able to serialize and deserialize the data from the database or from a request, what we want to have is a view. So the view, it's very similar to the serializer, but instead of using model serializer, we are using a model view set. So the view set is actually a group of views, and by default, it will give us all the actions. So if we look at the actual code from the Django REST framework, by default, we get the create, retrieve, update, partial update, destroy, and list actions. So what does it mean? It means that by default, this view set will provide us one view for each action. So we will be able to call different HTTP methods to access those different actions. So what we have to provide to our task view set, we provide a query set. So the query set is pretty much the set of data the view will work on. So here we give actually all the task objects we currently have in our database. And we give a serializer class, so the task serializer that we previously defined. So the last thing that we have to do now, now that we have our model, serializer, and view, we need to map our views to URL so we can access it. So a client can access those data. So the URLs are managed in the project and not in the application. And what we use is the DRF default router. And this router will define a namespace, a base name, and we will give it a set of views. And what it will do, it will create the URLs and map it to the views that we have. And then we register our URL within Django. And in our case, the URL will be API / and the to-do endpoint. So let's have a look. We will run the application, and we can play locally with it. I will have to share my browser so you can see the application. Share the correct page. All right, so I'm starting the server. And okay. Okay, so now I can access. So I'm running the Django development server, and now I can just access the local application. So I will just make it bigger. Okay. So one of the nice things and interest of using the Django REST framework is for development, it provides you with a default user interface. And you can also actually use that in production if you wish to have an interface for your API. And it can also be, you have also some other plugins and other applications that you can use to automatically generate the documentation and things like this. But by default, we can access, you have this nice user interface, and that lets you play around with your APIs, and that lets you test the APIs. So currently, in my test application and test database, I have 3 tasks, and I can access them on this endpoint, so /API/todo. I can use a form to create a new task. So let's do that. for example, by ladies remote, make a great demo, and that it's work in progress. Oh. And the gods of the live demo are not with me. Let me. Oh, okay, I know why. Okay, let's try this again. It wouldn't be fun if there was no errors. Let's try this one more time. Yeah, so we have a new application. So what I did, I just removed the old database and created a new database. So now we have only one task. So it's got the ID one, title, description, and status. So this endpoint API to do, let me get, so let me read data, but also create post. So you can see here in the UI, we can see the method that we use, the HTTP method. Now, if I want to access a specific task, I can give the task ID in the URL. So API to do one. And I get, instead of having a list of tasks, I will get the specific instance of this task. So what I can do from this instance, I can change the data. So for example, I can use this form and I can change the status from work in progress to done, and that will call the put HTTP method. And as you can see, it actually changed the status, but I can also delete a task. So that's done. And if I go back and request for the list of tasks, it's actually empty and I have no task stored in the database. As you can see, for development and when you are actually trying to test your new APIs, the Django REST framework HTML frontend is very useful, and it lets you play with the application without like having to write a lot of code. So now I will start locally OpneShift, and we will see how we can deploy and play with OpenShift on your machine. So I have to switch screen. I may be able to. Okay, so back in Visual Studio Code. So what I'll do, so I've already installed the OpneShift on my laptop, but it's actually very easy to install, and you can find the documentation online. Once it's installed, you can do OpneShift start. My OpneShift virtual machine is already running. we can actually start using it. So one thing we didn't look at yet, it's the application settings. So really the Django project settings. So while I was doing my test and running the application with the test server, I was using the local .py settings, and those settings were actually using SQLite database. But what we want to do usually in production, it's to have a database that runs in like PostgreSQL or MariaDB or something a bit more friendly for production. So in this project, I have another set of settings that's called production.py. And those settings is actually configured to use the PostgreSQL database. So what I will do, it's in OpenShift, I will create an application, an application in OpenShift that will run a PostgreSQL container. And then I will create another application that will run my to-do app containers. And those two applications with those two containers or pod will talk together. And my to-do application will be able to store and access data from the PostgreSQL database. Also, as you saw during the development, we had this nice user interface with HTML form, and it was very easy for me to test the application. But in production, I don't want to serve this application. I just want to be able to have some JSON. So here I set in the settings, I tell the Django REST framework that I only want to render my data using the JSON renderer. Okay. And now we will be able to log into OpenShift. So I'll show you how to do that using the command line. So by default, the username is developer and the password is developer also. I can see that I'm logged in and I can check the project that are created. And I'm currently in a test or demonstration project, my project, and that's the project that we will be using. So if you remember the diagram we saw of OpenShift, the applications and containers are running in pods. So we can, from the command line, check if there are any pods or application running. And we can see that currently we don't have anything running. So what we will want to do first is to create our application that will run our database. So the command is a bit long. I will just copy it and we can look at it. So what we do here, we just ask OpenShift to create a new application that will be called PostgreSQL. And we define some environment variable. That the PostgreSQL user will be to-do app, the Postgres database will be to-do app, and the password will be to-do app. And those settings are the settings that we defined in our Django database settings. So we have the name of the database to-do, the user, and the password is something that we will get from an environment variable. So we will see when we create the to-do app, how we give this environment variable. So splitting that. So what we'll do, it's on the right side terminal. We will just look at the pods that we are running on OpenShift. So for now, we don't have any. But as soon as I will create the PostgreSQL application, we should start to see some pods that are getting created. So you can see that OpenShift is currently deploying a PostgreSQL container. And it's already running, so it was like very fast. So we can look at the pods now. And we have a container, PostgreSQL 1. Oh, the deployment is running, okay. So PostgreSQL 1 deploy is running, and the actual container where the PostgreSQL database will be running is currently being created. So while it's getting created, we can now build our web application. So to do this, it's something similar command. It's just that instead of using PostgreSQL, we will be using the source to image Python 3.6 container. And that's what you see here. We do a new application and we use the CentOS Python 3.6 CentOS 7 image, and we give it the path of our GitHub repository. So that's the application that it's in GitHub, and we give it also the name of the branch we want to deploy. So here in my case, I want to deploy the production branch. And also I pass some environment variable. So for example, the Django secret key, so a very long and random string, and a database password to access PostgreSQL, and the name of the service where we run the database. So in our case, it's PostgreSQL. And this will be used for our web app pod to access the PostgreSQL database. So if I run this command and I start to look at my pods, you see that I have now a new pod that is started, and it's the Django REST framework to do build. So this build, it's actually doing a Docker build or a container build of my container. The build is running, and I should be able to look at the logs. I'll show you later on the OpenShift UI, the logs. While we wait, I will do that. Launch our pod. Okay, so the build is now done and our container is running. So now what I will show you is how we can create. So during the slide, we're talking about the OpenShift build and the OpenShift deployment. So now I will show you how we can ask OpenShift to create more containers for our web application. So as you can see currently, we are running one container in the pod. And I want to scale this. I want to have more containers running, so that if I have more load on the application can still cope with the load and all the requests. So to do this, I will look at the name of the OpenShift deployment configuration. So that's DC here. So OC get DC for deployment configuration. And I see that I have my to-do application. It's called Django REST framework to-do. So now I can ask, and I will put this second. Second terminal. I can ask OpenShift to create. So I can ask to create more containers from this build configuration. So I can ask OpenShift to scale the application, so OC scale, and to create three replicas of the deployment config, and the name. Just copy. And here you see that we are creating new pods. And now we have 3 pods where our web application is running. So now we have the database, one pod with our database, and 3 pods with our web application. But those pods are not available from an external client. Currently, they are only available within the OpenShift cluster. So the database and the web server, the to-do application can talk together. But if I wanted to access it from a browser or from another client, I could not. So I need to actually create a route to expose my service, my to-do application service to the world. So to do that, I need to look at the OpenShift service, so OC get SVC, and I see that I got 2 services, one that is the Django REST framework to do, and one that is PostgreSQL. And I can check if I have any routes. So currently, I don't have any routes. So what I want to do, it's an OC expose. And I want to expose the service. I will just copy that. Django REST framework. And what that does for me, it creates a new route. And now if I look at the route, I got a new route where I can access my application. So now we can test this, and for that I will use the HTTP command line, and it's HTTP client that you can use from a terminal. It's actually the Python project called HTTPy, and you can have a look at it. It's very useful when you are testing and developing REST services. So if I get like my route, because I need the URL. So what I want to do, it's an HTTP. I put it in -v for verbose, so we have a bit more information. And I want to send a GET request. And I will just copy the route. So I want to access my service. And this is the endpoint that you recognize from earlier. So I do the request and I get the response that everything is okay, but I currently don't have anything in my database, which is normal because we just deployed the application. So let's create some data. So the command is a bit long, so I will just copy it. Very similar, except that now we are sending a post request because we want to create, and we then set the data we want to send in this post request. So we set the title and the description and the status. So the answers from the server is that we have actually successfully created the resource, and we can see that we have the resource now. So if I do a get again, I now have one entry in my database. So what happened now if I work on my task and I want to update it? So what we can do, it's use the patch method to do a partial update. And this partial update is pretty much, it allows you to update only one field of the application. So in that case, I use, I want to update the status from the first entry, from my first task. And you can see that the status was in work in progress, and I want to set it to done. And it failed. Oh, okay. I'm using the correct address, sorry. So with the correct HTTP URL, that should work. And no, okay. It's 57 here. Okay. So now I updated my task, and the status went from work in progress to done. If I try to do that with a put request, I would get an error because the put method expects you to update all the fields of your resource. So here you can see that it's expecting me to provide a description and a title. So that's the difference between put and patch. So now what I can do, I'm done with this task. I just want to delete it. Very easy. I can just use the delete endpoint and check that we don't have anything in our database with the get endpoint. So this is where the CRUD design pattern is very useful, because you don't have to create one endpoint per action. You can just always reuse the same. So I'm always using API/to-do/ and I don't. You can see sometimes in some application you have like things like this. So you would have like maybe an endpoint create task, an endpoint get task, and you would always use either the get or post method. Oops, and the client will have to always change the endpoint and find the correct endpoint. With CRUD and Django REST framework, it's very easy. You always keep the same endpoint, and you just have to change your HTTP method. And also, it's the method is once you have a bit more familiarity with how it works. The mapping of the method is very straightforward. Say, oh, I want to get something. I want to create. I use post. I want to delete. I use delete. I want to do an update. If it's just a partial update, I patch it. Or if it's a complete update, I just use put. So it's very convenient, and it's very easy. Okay, so now I will show you. So now we saw how to. Oh, I will show you. OpenShift. From the front end, from the interface. So let me share the browser again. Okay, so I show you how to use the command line, but MiniShift also and OpenShift provides a nice user interface. So I'll maybe scale up so you can see what I do. So to log in, you can use developer. I didn't make a spelling mistake. And you arrive in what's called the web console, and you have a catalog of applications that you can use. So for example, we have used the PostgreSQL and Python application. So when I was typing on the command line OC new app, PostgreSQL and the CentOS 3.6, Python 3.6 were those two applications that are already provided to you. So that's what I was saying when I was saying that OpenShift is really focused on the developer experience, is that it provides you with a lot of those tools already available. And so if we click on my project, we can see the different application running. So we have our PostgreSQL pod, where we have, so we see that we have one pod running. And in this pod, you can look at the logs. And you can also have terminal access to the machine. So, if we come back to our overview, you can see our to-do application. And here you see that we currently have 3 pods running. And from the web application, I can like scale up. So I can ask to have 4 pods, for example, or scale down if I wish. And one thing I wanted to show also, so here are the deployments and the builds. So if you remember, we did a build from the GitHub repository. So you can see here the source, it's a GitHub repository. And if we look at the build logs, you can see that it's actually cloning the repository from GitHub. It's using a container image that it's source to image. So source to image is usually shortened to S2I. Maybe put a bit more bigger logs. And then the S2I image, so that we have a requirement.txt in our repository. So it detected this file, and it automatically installed the dependency we had defined in this file. So Django and other dependencies. And once the build is finished, it pushed the container to the OpenShift registry. All right. So now, and I can show you here from the browser that if you try to access the application using a browser, you don't have anymore the HTML user interface. We just get some JSON. So now that we have our application running in OpenShift locally, I will show you how to configure GitHub. How to configure a GitHub project to trigger OpenShift build automatically when you commit to a branch. So to do that, I'm not going to use my local mini-shift instance, but I'm going to use an OpenShift instance that is hosted in the cloud. So let me prepare. Checking if there are any questions yet. Okay. So the next part is we will do together. We will change the application, make a small change, open pull request in GitHub, and the GitHub project I got is configured to run some tests. So on Travis CI, once those tests have passed and are complete, we use an application, GitHub. I think it's called GitHub application. A GitHub application that will automatically merge the pull request. And once this pull request is merged, it will trigger an OpenShift build. So let me log into GitHub. Okay. Should have logged in before. Sorry about that. All right, so let's share my screen. First, we will make the change to our application and open a pull request. Application. Okay. So when we want to develop a new feature, we create a new branch. So what I want to do, I want to be able to add a tag to a task. For example, if the task is for work, I want to be able to tag it work. If it's something that I want to do at home, I can put home or anything, just like to be able to add some tags. So I create a new branch. And adding a tag, so I need to change my model, because now I want to store new information. So I will call it tag, and it's a model, and it's some kind of string. And the maximum length will be 255, and I can, and the tag doesn't have to be filled, so it can be blank. So that's it. That's why you see how powerful is Django REST framework. If I want to add a new field in my model, I just have to define it, and it will be automatically serialized, because in the serializer we define all the fields, and the view doesn't change. I'm still manipulating task. So the only change I have, it's one line of code, and it's to create a new field. So what I have to do in, if my terminal works. So what we want to do, because we changed the database, we have to create a new migration. So we tell the application how to migrate from one version of the task model to another one. My code editor seems okay. Okay, we are back. So in order to create a new migration, I use the Django manage.py, and I can ask him to make a migration for me. And I need to tell him which settings I'm using. So because this is, I'm doing some local development, I'm gonna use the local settings. And as you can see, it created a new migration file for me. And this migration file creates, what it does, it adds a new field to the task model, and the new field is a tag. So now that I have this, I can commit it and create a pull request. So I add my changes. Okay. And I add my new migration. And I can do a commit. So add a tag. Now I can push this branch to GitHub and open a new pull request. Okay. So now I'm gonna go in GitHub. So let me switch the screen share. Okay. That work. So here I've got my pull request, and before that, I'll show you the OpenShift project. So this is online OpenShift that it's hosted online in the cloud. And what I have already the PostgreSQL container application and our to-do application. So what we want to look at, as you can see, I got 2 pods for my web application. And what we want to see, it's how we will do continuous deployment. So I create my pull request. And what it does, it will start some test on Travis CI. That might take a few minutes. And once those tests are finished and done, the pull request will be merged. And once the pull request is merged, so here we can see that the tests are running. Once the pull request is merged, it will automatically trigger a build in OpenShift. And once the build is finished, it will automatically replace our 2 pods. It will actually recreate the 2 pods by new pods that are using the new version of the application. So just waiting on the test, we can have a look at the test. So you can see that it's currently installing the virtual environment to run the test. Travis is a bit slow. Oh, okay. So see, the tests have finished, and we have actually merged the pull request automatically. I didn't have to press on any button. And what happens here, OpenShift detected a new merge on the production branch, and it started to run a new build. So you can see that the build is running. The build is complete now. And OpenShift will start to scale down the pods and replace them with new pods. And now if I access my service, so on the API to-do route, you can see that I got now the tag field in my task. So to actually deploy a new version of my application in OpenShift and in production, I really just had to push a new commit to GitHub, open a pull request. The pull request was tested. We can imagine that if you work with a team, you could have requested someone to do a code review. And once the tests are passed and the pull request is approved, the application is automatically, once the pull request is merged, the build and deployment into OpenShift is automatic. So how does that work? It's working by using GitHub webhooks, and you have to define the URL of your project. So all this is in the OpenShift documentation. And pretty much when GitHub's detect. Pretty much GitHub will send every event, like merge or commit event on the branch to OpenShift. And that's how OpenShift triggers a new build. So that's pretty much all for me. So I hope that you saw how easy it is to build a REST service using Django REST framework, and within like very few lines of code, you can have like a service that allows you to create, read, update, and delete data, and how you can build a continuous integration and continuous development pipeline using OpenShift and GitHub, and this allows you to very quickly deploy changes to your application. So that's super useful. So I'll bring back the slides. You can see all the slides here. Some useful links with all the tools, and you have also the source of the application that it's on GitHub. So if you want to play with it, run your own OpneShift instance and try to run the demo locally. You can go through those links. Also, there are 2 articles on the Fedora magazine that I wrote, and that goes into a bit more details on how to install OpneShift, you can actually also build the to-do application from scratch, looking at those articles, like more tutorials than articles. Okay, that was all for me. Very happy to have shared this class with you. If there are any questions, I'm happy to take them in the chat now. So I'll put the link to the chat room again in the live chat if you want to join there. Otherwise, you can also ask me questions on Twitter. I'll be happy to answer them. So far, I don't see any questions. So we can give it a minute or two. All right, then. So if no question, I will end up the live now. Thank you, everyone, for joining. And if you watch the recording of this, thank you for watching it. And I wish you all the best, and I hope that this was useful for you. Thank you very much. Bye-bye.